Find the sum to n terms of the following series. Let us begin. So here we have a series, first term being 1, followed by 5, then we have 12, next we have 22, then we have 35, and the rest of the term. Now, this is not an arithmetic series because there is no common difference. However, if we take the second term, which is 5, and subtract the first term from it, that's going to give us 4. Let's take the third term, which is 12, and subtract the second term from it. That's going to give us 7. Next, we have 22 minus 12. That's going to give us 10. And then we have 35 minus 22. So that's going to give us 13. Now, clearly, we observe here that these new numbers that we have obtained after taking the difference of any one term from a previous term, we have 4, 7, 10, and 13. And we have the remaining terms. These terms are clearly going to be in arithmetic progression. So what we'll do? We'll suppose that let Sn represent this particular sum. Then the last term, we're going to represent the last term with Tn. And also consider the second last term, which is Tn minus 1. Next, what we'll do? We'll take the same sum Sn. And again, we're going to consider all of its terms. 1 plus 5 plus 12 plus 22 all the way up to the last term, which is, so that we have Tn minus 2 plus Tn minus 1 plus Tn. Now, we'll perform a subtraction here. Now, on subtraction, so Sn minus Sn, that's going to be equals to 0. We keep the first term 1 as it is. Next, what we do? We take 5 minus 1, so that's going to give us 4. Added to 12 minus 5, that's going to be 7. 22 minus 12, that's 10. 35 plus 22, that's 13. And this goes all the way up to the last term. So we have second last term, Tn minus 1. We're considering the last term of Sn, and from here subtracting the second last term of the next second Sn. And minus, we have the last term, Tn. Now what we'll do? We'll transpose this negative Tn to the left hand side to get Tn. So Tn is going to be 1 added to. Now what is 4 plus 7 plus 10 plus 10 plus 13 all the way up to the last term, which is Tn minus 1. This is an arithmetic series, and we know the sum of an arithmetic series has a standard formula, which is given by Sn equals to n over 2 multiplied to 2 times a plus n minus 1 times the common difference d. Okay. So here, first we have to figure out what is the total number of terms present here. Now, there will be a total of n minus 1 number of terms present in this arithmetic series. Now, let's try to understand why there are n minus 1 and not n terms. So, in Sn, what we did was we didn't include the first term. We excluded it. So, we considered the second term all the way up to the last term. And this has got n minus 1 number of terms because Sn has n number of terms. If we exclude one of the term, it's going to leave us with only n minus 1 number of terms. Next, in the second Sn, what we consider the first term all the way up to the second last term. So here we excluded the last term Tn. So therefore, we also have a n minus 1 number of terms. Now, during subtraction, we took an n minus 1 terms from the first Sn and again subtracted n minus 1 from the second Sn. So that means it's going to leave us with n minus 1 number of terms. So therefore, now we have the sum given by n minus 1 over 2. All we have to do is replace this n with n minus 1 because this n represents the total number of terms. This will get multiplied to 2 times the common difference, 2 times the first term, 4, added to, we have n minus 1, that's the number of terms, minus 1, multiplied to the common difference, which is 3. So we have Tn equals to 1 added to n minus 1 over 2 multiplied to 8 plus 3n minus 6. Further simplification is now going to give us, we have Tn equals to 1 added to n minus 1 over 2 multiplied to 3n plus 2. Okay, so let's combine this. So we have a common denominator of 2. Then we have 2 added to n minus 1 multiplied to 3n plus 2. So that's going to give us 3n squared minus n minus 2. Yeah, we can factor out the 2. We can cancel out the 2. So Tn, that's going to be equals to half multiplied to 3n squared minus n. So here we have obtained the nth term of the given series. Now that we have the nth term, our actual goal is to find out the sum to n terms. So we can easily find out the sum to n terms. So now the sum to n terms of the series that can be obtained by taking summation of the nth term. Only thing we have to do is replace the index n with k, and k is going to go from 1 to n. In other words, we have summation of, we have 1/2 times 3k squared minus k. Okay, so k is going to run from 1 to n. This is going to now give us 3/2 multiplied to summation k squared minus 1/2 times summation k. So k goes from 1 to n, and then we have k equals to 1 to n. Now, summation of k squared, this is simply, we have a standard formula. Summation of k squared is simply sum of the squares of the first n natural numbers. And that has a standard formula given by n times n plus 1 multiplied to 2n plus 1 whole divided by 6. So we can use this formula. We're going to get 3/2 multiplied to n times n plus 1 multiplied to 2n plus 1 whole divided by 6 minus 1/2 multiplied to, what is the summation of k? That's the sum of the first n natural numbers. So that's n. This will be equals to n times n plus 1 divided by 2. We have n multiplied to n plus 1 divided by 2. This is going to be 3 times 1, 3 times 2. That's n times n plus 1 multiplied to 2n plus 1 divided by 4 minus n times n plus 1 divided by 4. This is going to be equals to n times n plus 1 whole divided by 4 multiplied to 2n plus 1 minus 1. So we have 1 and 1 cancelling out. So this is now going to leave us with n squared over 2 multiplied to n plus 1. So this is going to be our final sum of the series.